In this example, I wanted to show you the idea of starting with some interpretation of a number and then being able to move that interpretation to binary, to hex, to unsigned decimal, whatever direction we need it to go. So for example, let's say we started with some digits in a register, binary digits in a register. Okay, and I wanted to make this conversion to hex. Hex is pretty easy. And then I wanted to interpret what's in the register based on a number of different things. Number one is unsigned decimal, Sine Magnitude decimal, and 2's complement decimal. Okay, so the way I would work this is I'm looking at this and I think, all right, these first 4 bits out of this 16-bit number is 1010, so 8 plus 2 is 10, so that's a hex A. And then we have 12, which is C, and then here was 12, and then we have 3, which is given here, and then 6. And so this is the hex representation. Sometimes we use 0H to represent that. Okay, so we went from binary to hex, and then I like to do that step first because I think it's easier to convert hex to decimal than it is to do binary to decimal. Okay, and so I'm looking at A is 10, and then this would be times 16, and numbering off the places here, 0, 1, 2, 3. This would be 16 to the third, plus, and then C is 12 times 16 squared, and then 3 times 16 plus 6. So we can add those numbers and get 44,086. All right, so next I'm asking about sine magnitude. Okay, so for sine magnitude, I check the sign bit. All right, so the sign bit is the most significant bit. It is a 1. Okay, so we know that means we have a negative number. And then we take the rest of the binary values and make that our magnitude. Okay, so that would be then we take these 3 digits. We don't include this 1 because it's the sign bit. These 3 digits, that's a binary 2. All right, so this would be 2 times 16 to the third plus C is 12 plus 3 times 16 plus 6. Okay, so if I did the arithmetic on that right, you get minus 11,318. All right, and then for 2's complement, if this number in the binary register is to be interpreted as 2's complement, all right, I again check the sign bit, and because the sign is a 1, I know this to be a negative number. So what I can do then is convert AC36 to decimal, which I've done here, and I would start with 44,086, and then I know the 2's complement is just found by, or the representation is found by subtracting 2 to the 16th. And so I get minus 21,450. Okay, so I started with the contents of a register, and I looked at the different interpretations. Okay, so to continue this example, what I want to do next is start in a different place. Okay, let's say I started with the 2's complement. So what would be the appropriate values in the binary register and or equivalently the hex digits? Okay, so what I would do here is think, well, because this is negative, what I know from 2's complement representation of negative numbers, this would be 2 to the 16th minus this number is equal to 34,915. That's base 10. And then what I do is I do a conversion decimal to hex. And I admit, I looked this up using MATLAB and got 0H8863. Okay. So had I not looked it up, I would have needed to divided the 16s in there to get this result. But the point here is not the mechanics of going des to hex. The point here is we started with a 2's complement representation, and we found out what the hex contents of the register that represents that number would be. Okay, so it would be 8863. So from there, I can expand the 8, 6, 3. All right. So a couple of things checked off the box here. All right, next, if I wanted to do sine magnitude, I can then start looking at the binary value here to see what the sine bit should be. Because that's a 1, I know this should be a negative number. And then I take the rest of the binary number and take that to be the magnitude. Okay, so from there, what I see is I get the 1000, the 8, oops, that's the wrong line, the 8 times 16 squared, right? That's in the 0, 1, 2 digit place. All right, so 16 squared plus 6 times 16 plus 3 is equal to, and I know this is going to be a negative number, so it's, you plug that in your calculator, you get minus 2147 base 10. Okay, so the sine magnitude representation of that register is minus 2147. Okay, and then finally, what is the unsigned interpretation? If we took an unsigned decimal interpretation of what's in the binary register, this would be, you know, I go to the hex line at this point, 8 times 16 cubed plus 8 times 16 squared plus 6 times 16 plus 3. Plug that all in, I get 3,400, or 34,915 base 10. Okay, so those are some examples. You should be able to take any place on this table and convert that up to the binary register and interpret that in whatever way, you know, one of these other 3 or 4 choices, you should be able to do that. Okay, hope that helps.